So, good morning students. Let me continue with Pythagoras theorem theoretical problems which are of tough session. So, ABC is an isosceles triangle. ABC is an isosceles triangle. The base BC is produced today. The base BC is produced today and D is joined to A. Right? In an isosceles triangle, in an triangle ABC is an isosceles, the base BC is produced to D and D is joined to A. Prove that AD square is equal to AC square plus BD into CD. AC square plus BD into CD. This is what we have to prove now. So how to do this one? So for this you need construction. Draw AM perpendicular to BC, right? Therefore, draw AM perpendicular to BC. Therefore, triangle AMB is congruent to triangle AMC. Why they are congruent? Because right angle, hypotenuse and side. Because AB is equal to AC. AB is equal to AC. And this is the common side and this is 90 degrees. By RHS property, the triangles are congruent. Therefore, what you can say? MB is equal to MC, right? MB is equal to MC. Now, consider triangle ACB. Consider triangle ACB. ACB. So here, if you consider this triangle, angle C is obtuse. Consider triangle ACB, in which angle ACB is ACD. Consider triangle ACD is obtuse. ACD is obtuse angle. So apply the theorem by theorem. And moreover, this is 90 degrees. AM is 90 degrees, right? Also AM is for AM. Also you can write angle AMC is equal to 90 degrees. AMC is equal to 90 degrees. Therefore, if you consider this triangle and this is the hypotenuse, so apply by theorem. Therefore, by theorem, what is by theorem? Therefore, by theorem, AD square is equal to AC square plus CD square plus twice the product of parts of the base. Product of parts of the base means MC into 2 into CM into CD. So this is equal to AC square plus, take CD common in these two. CD into CD is 2CD plus 2CM, right? So therefore AC square plus CD into CD plus 2CM. 2 into CM is nothing but BC. Here you have see MB is equal to, here MB is equal to MC. We have written MB is equal to MC. Therefore 2CM is nothing but BC. Since CM is equal to BM, right? 2CM, that means 2CM is nothing but BC length. You will get BC. Suppose if this is 4, 2 into CM, 2 into 4 is 8, no? So therefore BC is 8. This complete part is 8. 2 into 4 is 8 here. 2 into CM length is 4. So therefore complete part is 8. So this is an example. So AC square plus CD into CD plus BC. CD plus BC is nothing but CD plus BC. This part plus this part is nothing but BD. Is BD. So therefore AC square plus BD dot CD. BD into CD. Hence the theorem. Very simple. So only thing is you have to draw construction. Construction is very important. Draw AM perpendicular to BC. Also prove that the triangles are congruent, then and hence apply the theorem. Obtuse angle triangle. Obtuse angle, when there is an obtuse angle, you have to apply Pythagoras rule. I applied it. I now got the answer. Next one. Next one, how to do? Triangle ABC is a triangle. ABC is a triangle in which B and C are acute angles. B and C are acute angles. ABC in which B and C are acute angles. B and C are acute angles. If BE is perpendicular to AC, BE is perpendicular to AC and CF is perpendicular to AB. CF is perpendicular to AB. So they have given this condition. What we have to do is, what we have to prove? Prove that BC square is equal to AB into BF plus AC into CE. AB into BF plus AC into CE. BC square is equal to. So already we know that by Pythagoras theorem, if the triangle is acute and if this is 90 degrees, so what we have to do? Proof. Here angle B is acute. Angle B is acute and this is 90 degrees and this is also 90 degrees. If this is acute angle and this is a right angle, so are you following what I am saying? This is acute angle. Acute means less than 90 degrees, greater than 0 degrees. This is acute angle and CF is drawn perpendicular to AB. Therefore, by previous theorem, already I told, no, see my videos in the starting Pythagoras theorem. I told this is the formula you need to remember. Now the time has come to apply that formula here. Therefore, angle B is acute. Therefore, if this is acute, you simply should write AC square is equal to AB square plus BC square minus twice the whole product, the whole length, minus 2 times AB into BF. Now, similarly, consider similarly what? Acute angle C is acute. So apply that same thing. Angle C means this becomes the square. So AB square is equal to, please refer to the theorem of what I have done in the previous videos. Then only you can understand this problem. Otherwise you cannot understand. AB square is equal to what? AB square is equal to BC square plus AC square minus 2 times this whole length. Since angle C is acute, this whole length minus CA into CE. Mark this as 1, mark this as 2. Add these two. AC square plus AB square is equal to AB square plus BC square plus BC square plus AC square minus 2 times AB into BF minus 2 times AC into CE. Right? Now AC square gets cancelled, AB square gets cancelled. So BC square plus BC square is 2BC square. And when you bring this side, minus minus becomes plus this side. And take 2 common in these two. what I am saying is bring these terms to here, and this BC square will remain same. Bring this here. So 2 times AB into BF into AC into CE. So take 2 common. AB dot BF plus AC into CE. So 2 gets cancelled. So BC square is equal to AB into BF plus AC into CE. So AC into AB into BF is equal to AC into CE. Just apply that theorem, you will get the result. Very simple, nothing confusion. No construction is required, nothing. Just you have to remember the previous two, the theorem of acute angle based on Pythagoras, then the problem follows. Next one. The side BC of an equilateral triangle ABC, the side BC of an equilateral triangle ABC is produced to D such that CD is equal to BC. Prove that. This is another important problem. The side BC of an equilateral triangle ABC is produced to D. So here the side BC of an equilateral triangle ABC, the side BC of an equilateral triangle is produced to D such that CD is equal to BC. Such that CD is equal to BC. So here 60, 60, 60, right? The side BC of an equilateral triangle ABC is produced to D such that CD is equal to BC. This length is equal to this length. Prove that AD square is equal to 3 times AC square. Right? Prove that AD square is equal to 3 times AC square. So in order to do this one, what you have to do? Construction. Draw AM perpendicular to BC, right? Draw AM perpendicular to BC. So if this is 60 degrees, this is 120, right? Equilateral triangle, each angle is 60, right? So construction, draw AM perpendicular to BC. Therefore, angle ACD is greater than, so you can write here angle ACD is greater than 90 degrees, right? Greater than 90, obtuse angle triangle, obtuse angle, and AM is the perpendicular, and AM is perpendicular to BC, that is angle AMC is equal to 90 degrees. Therefore, by theorem, apply the theorem. What is that? Obtuse angle is there. So what does it state? According to Pythagoras, AD square is equal to AC square plus CD square plus twice the product of parts of the base, plus twice the product of parts of the base means MC into CD, right? Now here by theorem, consider triangle, you can write consider triangle ACD also, right? So AD square is equal to AC square plus CD length, CD is what given? CD is equal to BC given. given CD is equal to BC. So in place of CD I can write BC plus 2 times CM. CM length is what? CM length. So this 60, 60 and also 9. This we have read 90, 90 and this is the common side. So right angle hypotenuse side, and therefore you can write here CM is equal to BC. Therefore, if you want you can write previously triangle AMB is congruent to triangle AMC. AMB is congruent to AMC. Why? Because 90 degrees by construction and equilateral triangle opposite sides are equal and this is the common side. Therefore, by RHS property, triangle AMB is congruent to, you have done all the steps. Since you are in 10th class, if you don't write also nothing will happen, just write down RHS property. Therefore, MC is equal to BM. MC is equal to BM, right? So this CM length, how will you get? This is nothing but half of BC. CM length is nothing but half of BC into CD already given, no? CD, what is CD? BC. So 2 gets cancelled. So AC square plus BC square plus BC square. So this is nothing but, again, in an equilateral triangle, all sides are equal to AC, AB, BC. So this can be written as AC square plus AC square plus AC square, since all sides are equal in equilateral triangle. Are you following what I am saying? Therefore, this is nothing but 3AC square. AD square is equal to 3AC square. Very simple. Actually, there are different methods, but I chose this method, which is quite easy. First triangle ABC is an equilateral triangle given, so each angle is 60, 60, and I drew perpendicular, which is AM is perpendicular to BC. And what is the given condition? Given CD is equal to BC given. CD is equal to BC given. This is given. First you prove that these two triangles are congruent by RHS property. Therefore CM is equal to BM. And CM length is nothing but half of BC. Very important point here. CM is equal to half of BC. Then again apply the Pythagoras theorem. Since this is obtuse angle, apply that statement, you will get these conditions. Therefore simply replace the value. CD is nothing but BC and CM is half of BC plus BC into BC, BC square, AC is nothing, AC as it is BC. In an equilateral triangle all sides are equal. So AD square is equal to 3AC square, or they may ask AD square is equal to 3BC square, AB square, BC square or AC square. Anything they may ask. That's it, students. Have a nice day. Thank you. We'll meet you in the next class. Bye. Please don't forget to subscribe my channel. Click on the blue color icon button and subscribe it. Thank you, students. Bye.